Now that we've learned a little bit about lines that are being crossed by transversals and the different namings of those angles that exist there, we're going to take a look at some specific cases where there's some relationships that exist between those lines and then some certain relationships that exist between the angles that are created. And to start this off, we're actually going to do something a little bit different. We're going to take a look at this thing called Geogebra. So Geogebra is a dynamic graphing software that allows me to plot some points and lines and those types of things, but then also allow me to move them around. So I can create things like lines, and so GeoGebra really is helpful. If I want to create a line, for example, down here in the bottom left-hand corner, it'll tell me what exactly I need to do. And so as we know, if we want to create a line, what we need are 2 points. So if I want to create a line, I'm just going to select 2 points here, and this will be good. And then one of the great things I can do with this, I can make perpendicular lines, perpendicular bisectors, angle bisectors, all the different things. Or in this case, I want to look at parallel lines. So I'm specifically looking at the case whenever I have two parallel lines that are then intersected by a transversal, what happens. And so I need to select a point and then the line that I want it parallel to. So I have two parallel lines here, and the reason that we call it dynamic graphing software now is that I can move around the points on these lines, and they remain parallel no matter what. They locked in to that relationship. And so if I graph then another line, this will be my transversal, so it just intersects the two, I can still move these around. And then the only will be true though is that I still have these two lines that are parallel, and then I have this third line that cuts across both of them and goes through specifically these 2 points. So I can move this point of intersection around, which changes, kind of where my transversal at. I can change the slope of these two lines, but they'll always remain parallel, and I'll always have this other line that intersects both of them. And so now I want to look at the angles that are created. So I can use my angle measuring tool up here. It's going to require me to select 3 points to talk about the angles, so I actually need some more points on these lines. That wasn't actually on it. Undo that. But I need some points on these lines to actually talk about here, so I'm going to do that real quick. But then what I would do is I can use my angle measuring tool that requires me to select 3 points to measure these angles. And I can't remember the order I need to select these in. I think this is it. Nope. Okay. If I go the other way, how about this? There we go. So it tells me here that this angle measures 39.2 degrees. And again, the great thing about this is that if I move these around, what will continue to happen, if I move any of them around, here we go, then it will change that angle measure, so I can change it to be whatever I want. So the question is, what do you think is, well, first off, we knock some of these out before we have to think. These angles, I know this angle, its measure should be supplementary to the one that I had initially. I have this angle measure, which should be congruent to the one I had initially because they're vertical. And then I have this angle measure, which will be, of course, supplementary to my initial one as well. And so when I create these 4 angles here, and let me move them around so we can actually read them a little bit better. The great thing about these 4 angles is that they're all related to each other in some way, shape, or form. They're either congruent or they're supplementary to each other. And that's because they're either linear pairs or they're vertical. And so we get these relationships that exist. So the question is then, what do we think happens with these angles that are down here in this other set? And what we're going to end up finding out, and what will be the case, is that if I measure these, so if I talk about this angle, so this is the corresponding angle to the angle that I initially marked, we find out that it will in fact be congruent. And that's enough to tell me then that if this is congruent, that means that since this angle has to be supplementary to it, that means it's going to end up being congruent to this one up here. And so I can go around and I can measure all these angles, and what I'm going to find is that they all have the same relationships as this other set does. And so whenever I have 2 lines that are parallel and they're cut by a transversal, what I actually create are 8 different angles. They all have these unique relationships with each other. They're either all supplementary to, or they're all congruent with every other angle that's in here. And to kind of justify that to myself, I'm just going to move these around a bit. How about this point? Move these around a bit, and I see that no matter what, 43.79, 43.79, 136.21, I could go all the way around, and these will always be either congruent or supplementary to each other. Same thing here, and so I get all these values no matter how how these move. My corresponding angles will be all congruent, and I could actually take a look at some of these other ones as well. If I look at my alternate exterior angles, for example, they will be congruent to each other. My alternate interior angles will be congruent. My consecutive interior angles will be supplementary, and so on. And so what we're actually going to start off by doing is we'll prove a bunch of these things, but we need a starting point. So I'm going to jump back to my drawing space. And what we need is a starting point, and that starting point is a postulate, of course. We're going to take a postulate here that we're going to accept without proof. That postulate is the corresponding angle postulate. And what it tells me is that if two lines are parallel, then the corresponding angles are congruent. And so it's worth noting here, as long as we're here, this is not the first time, it won't be the last time that we're introducing a postulate that we are accepting without proof, but it could be proven. It's just beyond the scope of what we're talking about in class right now. And so don't think that this is like an unprovable fact. It is a provable fact. We could prove it. We're just not going to. We are accepting it without proof, and that's why we're calling it a postulate, and we'll use it to prove other things, which we will call theorems later. But so this is the corresponding angle postulate. If two lines are parallel, then the corresponding angles are congruent. And so just give a quick sketch of this. So if I have two lines are parallel, so I'll mark all these lines. If I have two lines are parallel, and they're cut by a transversal here, and I'll mark that they're parallel, the corresponding angles will always be congruent to each other. So that will always be the case. And so that can lead me to some interesting things then that's worth noting. Let me just go ahead and bring up a new page. And so if I have two lines that are parallel, I'm going to be able to talk about all the different angles that are created and their relationships and give a good reason for why they have that relationship. So I'm just going to pick an angle measure here. I'll pick my favorite angle measure. How about we'll go with 60 degrees. 60 degrees. So let's say if I say this angle is 60 degrees right here. I can work my way around and then name or give a measure to every single one of these angles in this diagram. And so I can start with these. This pair of angles right here is going to be 120 degrees and 60 degrees because they're supplementary. These two angles are vertical angles, so they will be congruent to each other. These two angles are vertical angles, so they will be congruent to each other. Also, it's worth noting that these are supplementary and these are supplementary. And then I can use my corresponding angle postulate to say that since these two lines are parallel, these corresponding angles will be congruent as well. And so I can work my way around again and say this has to be 120 degrees, this has to be 60 degrees, this has to be 120 as well. And so we could chain some things together to say that, well, since these two angles are corresponding angles, they will be congruent. And since these two angles are vertical angles, they are congruent. And that means that then our exterior angles are always going to be congruent because they're always going to have those pairs of relationships. So that's something that we'll be able to prove here and talk about the fact that if two lines are parallel, the alternate exterior angles will always be congruent to each other. So this is just a little introduction into the relationships that can exist between angles whenever I have parallel lines that are intersected by a transversal. And all these proofs that we're about to do next are going to be, relatively easy to do. I just have to accept the fact, though, that all of them start off with that if the lines are parallel. And that's actually maybe worth going back to and talking about for a second, is that what has to be true here is these two lines have to be parallel. That's the hypothesis of my statement. Just whenever I have two lines that are intersected by a transversal, it doesn't mean that the corresponding angles will always be congruent. That's only true if the lines are parallel. So, like I said, we'll use the corresponding angle postulate to prove a whole bunch of things later on, but this is just a starting point that we will take off from later.